Okay, guys, today we're going to talk about whether or not you should believe a statistical study, right? Now, there are several guidelines for evaluating a statistical study. So, the first one is to get a big picture view of the study. You should understand what the goal of the study was, the population that was under the study, and whether the study was an observational or an experiment. All right. Now, second, you want to consider the source. You want to look for potential sources of bias on the part of the researchers, right? Part three, look for bias in the sample. Decide whether the sampling method was likely to produce a representative sample. For four, you want to look for problems in defining or measuring the variables of interest, right? So there might be ambiguity in the variables that could make it difficult to interpret the results. Right. The next one is to beware of confounding variables. So if the study neglected potential confounding variables, its results may not be valid. And we'll talk about that a little bit more once we get there. Now, the sixth thing is to consider the setting and wording in surveys. Look for anything that might tend to produce inaccurate or dishonest responses. 7, check that results are presented fairly. Check whether the study really supports the conclusions that are presented in the media. And for 8, stand back and consider conclusions. Evaluate whether the study achieved its goals. If so, do the conclusions make sense and do they have practical significance? Okay, so in example 1, we're imagining the following hypothetical news report. So researchers gave 100 participants their astrological horoscopes and asked whether the horoscopes appeared to be accurate. 85% of the participants answered yes, and the researchers concluded that horoscopes are valid most of the time. And we want to analyze this according to Guideline 1. Now, Guideline 1 says we should understand the goal of the study, the population that was under study, and whether the study was observational experiment. Right? Now, of course, the goal was the accuracy of horoscopes. Right? But also, what does this mean? Right? What do we mean by valid or accurate horoscopes? Right? Now, also, who are the participants? Right? What did the horoscopes say? Or where are they from? Right? So there's a lot of things that are kind of off about this statistical study, right? We don't know what accuracy of horoscopes mean. We don't know who the participants are other than there's just 100 of them. And they only answered one question that's kind of vague in general, right? So that would give us some things to raise a red flag about. All right. Now, in example 2, by 1963, enough research on the health dangers of smoking had accumulated that the Surgeon General of the United States publicly announced that smoking is bad for your health. Now, research done since that time has built further support for this claim. However, while the vast majority of studies show that smoking is unhealthy, a few studies found no dangers from smoking, perhaps even health benefits. These studies generally were carried out by the Tobacco Research Institute and funded by tobacco companies. So analyze the Tobacco Research Institute studies according to Guideline 2. Now, Guideline 2 is to consider the source, right? Now, of course, the Tobacco Research Institute would want to make smoking seem great. Because smoking is their livelihood, right? Without smoking, the tobacco companies and Tobacco Research Institute wouldn't have a job, right? So of course they're going to try and undermine any reports that smoking is bad for your health. All right. Now, in Guideline 3, we talk about bias in the sample. Now, selection bias occurs when researchers select their sample in a way that tends to make it unrepresentative of the population. Right. So, for example, a pre-election poll that surveys only registered Republicans has selection bias because it is unlikely to reflect the opinions of all voters, right? Because there's two parties. Now, participation bias occurs whenever people choose to whether or not they want to participate or not. So for example, if participation in a survey is voluntary, people who feel strongly about the survey issue are more likely to participate, so their opinions may not represent the larger population that is less emotionally attached to the issue, right? So surveys of poll in which people choose whether or not to participate are usually called self-selected or voluntary response surveys. Okay, so in example 3, we want to look back at the chapter opening question, which offered 5 possible choices for a survey on Americans' views of a new health care plan, right? So we already know that the correct answer is A, the carefully conducted poll of just 1,000 Americans. So they're talking about um, which of the samples would be representative, right? So the idea here is that we would want to have a representative sample can be chosen by not having any bias, right? Right. So I don't want it to dig up the question. I'd have to find the textbook here. But the idea is that the representative sample can be attained by not having any bias in the selection. Okay. Now, the next guideline says to look for problems in defining or measuring the variables of interest. All right. Now, a variable is any item or quantity that can vary or take on different values. Now, the variables of interest in a statistical study are the items or quantities that the study looks to measure, right? So it's important that your variables are easy to measure and clearly and easily defined, right? So in example 4, we have that a Roper poll reported in USA Today involved a survey of the wealthiest 1% of Americans, right? So the survey found that these people would pay an average of $487,000 for true love, $407,000 for great intellect, $285,000 for talent, and $259,000 for eternal youth, right? Now, according to guideline 4, look for problems in defining or measuring the variables of interest. Well, of course, this is red flags all over the place, right? Because what is true love? How do you measure true love? What is great intellect? How do you measure that? What is talent? How do we measure that? And what is eternal youth? How do we measure that? Right? So here, these variables are not clearly defined. Or measurable. Right, so those are major problems with this type of wording for these different variables. Okay, now in example 5, we have that a commonly quoted statistic is that law enforcement authorities succeed in stopping only about 10 to 20% of the illegal drugs entering the United States, right? So now, should you believe this statistic? Now, this is tough to believe. And it's tough to believe for a couple of things, right? Because how do we know how many illegal drugs are coming in? Because, they don't go to law enforcement and say, hey, I have illegal drugs, and we write it down, right? So it's tough to believe because we really don't know how many illegal drugs are entering the United States. Right, so it's tough to put 10 to 20% on that if we don't really know how many illegal drugs are entering the United States. So this is one of those statistics that's a little bit that would be tough to believe, right? Now, the next guideline is to beware of confounding variables. Now, confounding variable is variables that are not intended to be part of a study, but they can sometimes make it difficult to interpret results properly, right? So for example, in this example, we have that radon is a radioactive gas that's produced by natural processes. So it's the decay of uranium mostly in the ground. Now, the gas can leach into buildings through the foundation and can accumulate in relatively high concentrations if doors and windows are closed. Now imagine a study that seeks to determine whether radon gas causes lung cancer by comparing the lung cancer rate in Colorado, where radon gas is fairly common, with the lung cancer rate in Hong Kong, where the radon gas is less common. Now, suppose the study finds that lung cancer rates are nearly the same. Is it fair to conclude that radon is not a significant cause of lung cancer? And this, of course, would be no, because of confounding variables. Right? So, for example, maybe in Colorado, do they have more smokers? Right? Maybe access to medicine in Colorado is not as easy as it is in Hong Kong, right? So there's potential confounding variables here. So that's what we need to keep in mind. Okay. Guideline 6, consider the setting and the wording in surveys. Now, especially when surveys are not guaranteed complete confidentiality, participants in a survey may not be completely honest. And of course, the wording can contribute to different responses as well. Now, in this example, we have that the Republican National Committee commissioned a poll to find out whether Americans supported their proposed tax cuts. And they asked, do you favor a tax cut? A large majority answered yes. Now, should we conclude that Americans supported the proposal, right? Now, of course, everyone would favor a tax cut, right? Now, what we might not be getting here is we might not be getting the full story. Right? Would the tax cuts mean maybe a loss in government services? Right? So for example, trash collection or plumbing or something like that. That's one thing that we're not getting here, right? And also, what is a large majority, right? Right? And also, which Americans did they ask? Right? If this is a Republican National Committee, did they only ask Republicans? Right? So this section is really about sort of being able to play devil's advocate, and is it possible to poke holes in a statistical study? Right? Now in guideline 7, we want to check that results are presented fairly. So oftentimes, especially when researchers have personal bias, results may not be presented fairly. And of course, there's misleading graphs that could be a common problem as well. Now, in example 8, the school board in Boulder, Colorado created a hubbub when it announced that 28% of Boulder children were reading below grade level, right? And hence concluded the methods of teaching reading need to be changed. Now, the announcement was based on reading tests on which 28% of Boulder school children scored below the national average for their grade, right? Do these data support the board's conclusion? And of course, this would be no, right? Because just because 28% scored lower than national average, right? National average and at grade level are different, right? Anybody that's had a background in education can tell you this, that national average and at grade level do not mean the same thing, right? But they're sort of using these two things interchangeably, right? So they're saying below grade level and below national average for their grade, and they're saying that those are the same thing, but in fact they're not, right? National average for their grade could be below grade level, right? Being at grade level for reading comprehension means that there's some sort of established guideline based on how a child at a particular grade level should be able to read and process information based on the complexity of the language that's used, right? So the bottom line here is that at grade level and national average are not the same thing, even though they are presented as being the same thing, okay? And then, of course, the last guideline is to stand back and consider the conclusions. At the end of a study, you should ask yourself, did the study achieve its goals? Do the conclusions make sense? Can you rule out alternative explanations for the results? And if the conclusions do make sense, do they have any practical significance? Right? So in this example, which I believe is the last one, yep. So an experiment is conducted in which the weight losses of people who try a new fast diet supplement are compared to the weight losses of a control group of people who try to lose weight in other ways. Now, after 8 weeks, the results show that the treatment group lost an average of 1/2 pound more than the control group. Assuming that it has no dangerous side effects, does the study suggest that the fast diet supplement is a good treatment for people wanting to lose weight? And the answer here is probably not, right? And the reason why it's probably not is because is 1/2 pound, and let's see, how many weeks was this given? After 8 weeks, 1/2 pound in 8 weeks, is that a significant difference? Probably not, right? So 1/2 pound in 8 weeks is not a huge difference, right? And what other ways, right? Lose weight in other ways. What other ways were used, right? And who's deciding if these side effects are dangerous or not, right? Right. So these are all other things that we should consider according to this guideline, right? Um, so it's possible that we have alternate explanations coming into effect here, and things like that. So that concludes this video on should you believe a statistical study. I hope you enjoyed, and I will see you next time.